Okay, for some students, these may be a little bit tricky. And I want to just talk about that arc sine. And I'm going to write y equals arc sine. Now, I want to discuss this before I go through the problem. Now, what does that mean? It means sine of y is equal to x. All right? So, before I move forward, I want to talk about the invertible region of the sine function. And the invertible region of the sine function, we try to stay close to the origin, is between minus pi over 2 and pi over 2. All right? So I want to talk about the range of this, and this is the invertible region of the sine function. This is the sine function. It goes from minus 1 to 1. So when we look at this over here, we say the domain of this is going to be from minus 1 to 1. And we're going to say the range of this over here is going to be from minus pi over 2 to pi over 2. All right? So I kind of understand that part, and that part is right here. I got that part done. All right? I know that. I got trouble, though. And my trouble is I need to take the secant of this. So someone says, what is this thing pumping back? It pumps back between minus pi over 2 and pi over 2. And by the way, I know that there's two numbers there that I can't let in. And to prove that, I can't take the secant of minus pi over 2 or pi over 2. So what I'm going to do, I'm going to restrict this x to the interval between minus 1 and 1. And why is that? It would exclude these ones over here. So I need to exclude that. All right? So what I do now is I think about it, and I'm going to write this down for you. I'm going to get my my eraser out. I'm going to erase this picture over here. I don't need it anymore. That would just help me to remember certain things. I'm going to erase this business over here. Erase this. I'm going to start to write this down now. Now, granted, your teachers may do different things, but I'm going to write down the secant of y. All right? And then I'm going to write that as 1 over the cosine of y. All right? Now, before I go on, what I want to claim is if I'm doing this over here, the arc sine is going to be between, this is of x, by the way, is going to be between pi over 2 and pi over 2. Now, what do I know about the cosine curve in the interval? It's positive. So I'm safe now. What am I safe? Safe using, I'm going to say a right triangle now. So let me go through that with you. And I'm going to talk about this business over here. This is y, which is the angle. I'm looking at this. And what's the ratio going to be? Well, the ratio is going to be, let's see, x over 1. Use Pythagorean theorem here. And again, I'm safe in doing this. It's going to be 1 minus x squared. So let's take a look at this. What do you get over here? You get 1. What's the cosine of y? And that's really what I'm trying to do, because y is equal to the arc sine of x. Cosine of y is just this. That's how most teachers do it, by the way. So what do we do over here? I'm going to say this over here. Secant of arc sine of y is going to, I'm sorry, not y. That's not there. Not even there. It's x. Sorry about that. Is equal to 1 over the square root 1 minus x squared. With the understand the x is on the interval between minus 1 and 1. All right? So what I want to do is just look at the k and see if I see that. I do see that. I notice you're not putting the restriction down, so that's fine. Most teachers don't put the restriction down. Get this over here. I do want to talk about the key, though, right? So when we're looking at that, I recommend you read it. So, domain of the arc sine, we did talk about that. The range of this, we did talk about that. We need to restrict the domain to this over here because the secant is undefined at plus or minus pi, right? And it goes on to say the secant, or even the cosine, is positive on that interval, by the way. We only need the principal root. It does say that, right? Let's go take a look at it. And by the way, I will graph both so you can see that. What do you mean by graphing both? What they've given me and what I said it is, and I'm going to say it's true on that interval over there. All right, let's go through this over here. It looks very similar to what we did in before. And then, I did this over here. But I'm doing something different now. And I want to point out what I'm doing over here. I'm squaring both sides, all right? So when you square both sides, what do you get? You get sine squared equals x squared, all right? And someone says, why do you do that? I'm looking for a Pythagorean identity, all right? Now, why is that? I'm looking to come back at some point to take the secant, but let's keep working through it. What I do over here is, I multiply both sides by -1, and then I add 1 to both sides, and I get this over here, all right? Then what do? You notice that 1 minus sine squared y, I want to get the cosine, by the way, because it's related to secant. I get cosine squared. What's cosine squared? It's equal to 1 minus x squared. Now again, remember what I was saying about this over here, that the cosine of that angle, whatever it is, it's going to be positive, all right? It's going to be above the 0. And why do I know that? I've taken the x to be on the interval between -1 and 1, all right? We've discussed that right up here, by the way. So what I do, I take the square root, but I don't need to do plus or minus because the cosine of y is positive. So I get this over here. The next thing I do is take the reciprocal, and what do you get over there? The secant of y is this over here, the reciprocal. And then I go back and plug the y in. What's the y? It's this over here. And what do I get? I get this over here. This looks different. For a lot of students, this is something a teacher wouldn't have done that. What do? They do those right triangles, sometimes without even discussing the restrictions on it. But again, you probably should think about that, all right? I know it's difficult. Thank you.